In this video, we're going to talk about reading limits from graphs. This is a very important calculus skill. Finding limits is important for all of the important areas in calculus, and we can't really understand limits algebraically until we understand limits graphically. So that's what we're talking about here. Okay, here we have a graph of a function. It happens to be the function f of x equals x squared, and there are three different limit questions we're going to look at. The first one is red, limit as x approaches 2 from the left of f of x. This little minus sign here doesn't mean a negative sign. It's just a notation that means coming in towards 2 from the left. So this is asking us to look at x values that are getting close, really close to 2, like 1.9, 1.99, 1.999, really close to 2. And then it's asking us what is happening to the f of x values. Remember, f of x means the y values. So as I come along this graph with x's corresponding to these x's getting close to 2, I'm traveling along the graph like this. The question is, what are the y's approaching? What are the y's getting close to? Well, we see we're getting really close to this point, 2, 4, and so we say the limit as x approaches 2 from the left of f of x is 4. The second question is almost the same thing, except this one has a plus sign. Again, it doesn't mean positive numbers necessarily, although in this case they will be. What it means is coming in from the right-hand side of 2. So now we're looking at these x's coming in towards 2 from the right-hand side. We go up to our curve to see what are those y's doing. So on the curve for those x's getting closer and closer to 2, we're traveling along the curve that way, and again, the answer is 4. Now, for this particular function, it's also the case that there is a point at 2, 4. That is not what problems 1 and 2 are asking us about. The way that we would ask that question is, what is f of 2? What is the y value for the function f when x is 2? Well, that happens to be 4, and in fact, for the vast majority of the functions that we deal with in algebra and in calculus, they are continuous. We'll talk about that later in the course. That means we can draw their graphs without lifting up our pencil. And so what we're getting closer to is where we actually have the point. Now, the last question we have for this graph is, what is the limit as x approaches 2 of f of x? This time it doesn't specify from the left or from the right, and so that means look at both coming from the left and coming from the right, and we will report out a finite answer only if the left-hand limit and the right-hand limit are the same thing, which they were in this case, and so the limit as x approaches 2 of f of x is 4. Okay, let's look at a second example. In this case, we have another function, y equal f of x, and this time we've got this rogue point up here when x is 1. If the question were, what is f of 1? What is the y-coordinate of the point whose x-coordinate is 1? Our answer would be 4. However, let's look at the limit statements. Remember, they're not asking us what happens at 1. They're asking us what happens as we get close to 1. What were we approaching? So the first question is asking us as x gets close to 1, coming in from the left-hand side. I go up to my graph and I look at that portion of the graph for those corresponding x values, and I see that the limit as x approaches 1 from the left of f of x is 2. The next question asks us, what is happening to the y values if x gets close to 1 coming in from the right-hand side? So now we're on this piece of the graph. And again, we see that we are getting closer and closer to 2. The third question is the two-sided limit question. What happens as x approaches 1 to our f of x values And again, we have this situation where we got the same answer coming in from the left and coming in from the right. And so the limit as x approaches 1 of f of x is 2. Okay, next example is what we call a piecewise defined function. That just means the graph comes from pieces of different functions. And I have a typo on that. I'm sorry about that. Easy to fix. Okay, first question. What happens as x approaches 1 from the left? Okay, we know where to look. We come up to our graph. The piece of the graph that has x's to the left of 1 is this piece. And so we're coming in here, and we see that the limit as x approaches 1 from the left of f of x is 2. But next question, x approaching 1 from the right, we're looking at these x's. That's this second piece of the graph, this one up here. And this time we see that the limit of f of x as x approaches 1 from the right is 4. And so the limit as x approaches 1 of f of x, the two-sided limit, is not 2, is not 4. We got different answers from the left and the right. And so this limit does not exist. And so I really can't have this equals here. I'll take it out. It's gone. And we abbreviate does not exist very frequently, DNE. Or we say the limit is non-existent. If we asked the additional question, what is f of 1? That's asking us, where is the actual point that has an x-coordinate of 1? And we see that that is this point right here. F of 1 is 4. It happens to match the right-hand limit, but it doesn't match the left-hand limit. Okay, I want to talk about one more sort of situation. And this is the case where we have infinite behavior in our graph, one way or another. So I've got 8 different limit statements we're going to look at here. This time we have a function y equal g of x, which has a whole lot more going on in it than the other examples did. And our first question is, what is the limit as x approaches -1 from the left of g of x? What's happening to these y values as our x's get closer and closer to -1 coming in from the left-hand side? Well, we see from this part of our graph that those y's are getting taller and taller and taller, bigger and bigger and bigger, going up towards positive infinity. This limit does not exist. And in fact, if this were multiple choice and non-existent or does not exist was a choice, I would happily pick that choice. But we often will write positive infinity for this limit as a way of describing what the graph looks like, in this case where the limit does not exist. I prefer the plus infinity because it tells me a lot more than the does not exist alone. It tells me this graph is shooting up towards positive infinity. The limit as x approaches -1 from the right. Now here's where it's important to keep our head on straight. This doesn't mean positive numbers. We're getting close to -1, but from the right-hand side. So like -0.9, -0.99, we're coming in here. Where are our y values for this portion of our graph? They are coming down here, approaching negative infinity. And again, the limit does not exist, but negative infinity is a way of describing how that limit does not exist. So we could say does not exist, or we can say minus infinity. On the AP exam, they would never give us a multiple choice question with both of those choices. We would either have negative infinity or does not exist, and either one of them are the right answer. The negative infinity is just more descriptive. Third question, what is happening to g of x? Let me number these. Third question, what is happening to our g of x values, our y values on this graph, as x approaches -1, both from the left and from the right? Well, neither the left nor right-hand limits existed, so certainly this limit does not exist. And in fact, we have different behavior coming from the left and from the right. So I can't say plus infinity, I can't say minus infinity, and so in this case we do say does not exist. If I want to really describe what's happening, I break it out and look at the left and right hand limits separately and see that from the left it's going up towards plus infinity, coming in from the right it's going down towards negative infinity. Okay, let's contrast that behavior at that vertical asymptote x equal -1 with this, what's happening at the vertical asymptote x equal 1. So what happens as x approaches 1 from the left? Hopefully you are answering along with me. The answer is plus infinity. What's happening as x approaches 1 from the right? We're looking at these x's. Again, we're going up towards plus infinity. The limit is infinite. The limit is not a finite number, so the limit does not exist. But we do have the same behavior on the left and the right. And so the limit as x approaches 1 of g of x does not exist, but we can describe it more fully by saying that limit is plus infinity. So again, in a multiple choice question, we would choose either does not exist or positive infinity, whichever of those happen to be there. If we had plus infinity and minus infinity as two of the choices and did not have does not exist, I hope we would not have does not exist, our answer would be plus infinity. Okay, let's look at one more question, one more pair of questions. This time we have infinite behavior, but in terms of the x's. In the first case, we're talking about x approaching negative infinity. This is asking about end behavior to the left of our function. So we're looking at x's going way, way out there to the left, farther than I can see on this graph, all the way out there. And the question again is asking, what is happening to the y values? Well, if they are settling down towards some horizontal line, which is the case here, if we have a horizontal asymptote, then this limit is a finite number, and in this case, the answer is 0. The second one is asking us what happens as x approaches, typo here, this should just say plus infinity. What happens as x approaches positive infinity for these y's? We're asking what happens way out here to the right. What is the end behavior to the right of this graph? And again, we are approaching 0. So I hope that helps you understand how to read limits from a graph. And with that understanding, you're ready to start looking at algebraic limits.